Okay, well, I've invented the world's strangest battery. Okay, it's a very unusual battery in so many ways, and I figured I would show you the battery and I will show you how to build one. Now, there'll be numerous methods, but this is just what I've done so far. So, the battery is very unusual. It has, for starters, it has infinite equivalent series resistance, which no batteries normally do. It has infinite equivalent series impedance at all frequencies that I've been able to test it with. It also, another unusual thing is it has 100% dry electrolyte. Now, all batteries and cells that I know of, including what we call dry cells, actually have some water. Even dry cells, they're just not as sloppy as wet cells, right? Where this has absolutely no water, right? And so we've got the multimeter here showing DC, and this is the battery, okay? The copper is more positive than the aluminium. They say aluminium, or aluminum for my American friends, has more valence electrons than copper does, which makes it more negatively charged than copper. And it's that principle that I'm working with. Now, the electrolyte that I'm using is ash from my wood heater. So I get a sieve and I filter out, shake out the fine grey ash. I don't want the black sort of activated charcoal type, or activated carbon ash. I want the grey, fully burnt ash, really fine. Okay. Now, but I'll show you how to build in a sec. So we'll have a quick look. I've got the multimeter here, and this is the copper end, which would be the positive, and this is the aluminium end, the negative. So I'll connect the negative end to the negative terminal. Just put my pen down there. And the positive end to the positive terminal. And if you have a look at the multimeter, you see it started over 4 volts, but it's dropping a little. Okay. Now, it's a voltage battery. It doesn't give much current at all. If I connect a 1.5 volt LED across this, I have to go into a very dark room to see that it's slightly illuminated. Now, of course, you could make more of these and have them in parallel, and also more in series to bring up the voltage. But take a look at the voltage. I'm going to release and then reconnect. And it comes straight back up. Release, reconnect. Release, reconnect. Now, I don't know if I need to point out that it doesn't need charging, that it's not about charging, okay? I never did charge it. It is using the natural potential of the metals. Now, it is unusual that I've managed to achieve 100% dry electrolyte or bridge. Now, hopefully you can see here this diagram. I hope it's clear enough. Now, I've marked here in the colors: green for wood ash, blue for aluminium or aluminum, and red for copper. Okay, so how it works is, and I'll explain my construction, but I'll explain the basic fundamental first. So let's say at one end you have aluminium, okay, as your negative end. Then you create a bridge of wood ash, okay. Then you have an electrode of copper, and the copper must then be connected to an electrode of aluminium. And then you have a bridge of wood ash. And then you have a plate of copper connected to a plate of aluminium, and then a bridge of wood ash, and then finally a plate of copper for your positive end. Now this diagram here, let me see, 1, 2, 3, this would probably give you about 1.5 volt, okay, because there's 1 cell, 2 cell, 3 cell. You'd probably get more voltage if you wet it, but the problem is then you'll get a redox reaction and it won't last for very as long. This should last for years because no water, there's no real redox reaction. So obviously to get higher voltage, you repeat this process, but you make sure that you always finish at one end with the opposite sign to what you started with. Now, if you wanted to increase the small amount of current that it gives, of course you could make more of them and add them in parallel as well, not just many more in series. Now this is actually quite heavy because I've used magnets, but I've only used magnets for the purpose of keeping a good contact pressure between, let's say, the Al and the copper across the bridge of the wood ash. Because if it gets a little bit relaxed, the voltage will drop considerably. So it needs real good pressure contact. So just for now, I've come up with that method of using magnets because that helps pull it all together. So how this is constructed is I used little disc magnets, and this is just a drinking straw that happened to be about the right size for the magnets to fit in loosely. So I got a bunch of the magnets, and some of them I wrapped in copper foil, and some of them I wrapped in aluminium or aluminum foil. Okay, and how I did it is I put, let's say, at the bottom, an aluminium one in the bottom. Okay, now because I'm using magnets, I had to make sure I always got the polarity correct. So aluminium one in the bottom, and let's say the north pole pointing up. Then I sprinkled in some wood ash, make a nice little gap with wood ash, and then I got two more magnets, one that has aluminium and one that has copper, and stick them together. But I had to make sure, because if this was the aluminium at the bottom, that the next one's going to be copper. So I had to make sure that I had copper then aluminium with the two magnets, and of course make sure the magnetic polarity was going to be correct. So if I wanted copper and aluminium at the bottom, I had to make sure that the copper stuck to the bottom at here. So then I know I had the polarity correct, and drop it in, push it down onto the bridge of wood ash, and then the magnetic field was helping pull them together. That's the only reason I've used magnets, so no magic miracle energy there. Okay, and just repeating that process. So I will be able to make one much lighter. Like I'd be able to get the same sort of voltage out of something like this that's only this long or smaller and super lightweight. And then of course it would be easy to make many more in series and in parallel, and I just thought I'd share that with you. Now there may be some skeptics that will say, oh yeah, you've hidden a 1.5 volt battery or little button batteries in there. Now to try and prove you wrong, I'll see if I'll hold this steady, right? You can see I've got the voltage there. If I was using normal cells, it would it would show the resistance across the cell. So I will go into ohms, and you'll see I have infinite resistance. It's like a complete open circuit, which would not be the case with little button battery cells or anything like that. This is truly infinite equivalent series resistance, and like I said, I have tested this at various radio frequencies, and I cannot see a whisper of a tickle on any RF frequency I've applied through this system. And I'll go back to DC voltage, and you can see there she's up there over 3.6 volt. And like I said, if I release and then reconnect, she comes up very quickly. So if you've been following my channel for a while, you probably have sussed out where I'm going with this. Hey, it restores very quickly, right? It doesn't really provide current, but it does provide a voltage spike very easily. And since I'm playing with infinite impedance systems with my antenna projects, and my main objective is to cancel currents, which is magnetic work, in order to increase the E fields, then employing something like this within a high Z resonance system, and nothing can go through it, it will only ever add in the E field. It will add voltage spikes, and it will polarize the system. So I just thought I'd share that with you. 7-3, and thanks for watching. This is Crazy Ham, VK3 VKE.